Alright, in this video I'll be talking about how we can use Excel sheet to do the curve fitting using some data points. So that is section 4.3 on page 91. Okay, so I think the best way to do this is to begin with an example. That is going to be example 4.4 of the textbook. So we have a table like this. We have time in the first column. We have the carbon dioxide rate. I think that is going to be the fermentation reaction, right? So this is the rate of creation or generation of CO2 given in this column, and oxygen generation given in this column. Okay, so just to make sure, okay, that is the rate of O2 absorption and CO2 generation. Okay, so we want to calculate the total volume or the total mass of CO2 and oxygen that is used and produced using trapezoidal integration. So if you have the rate, then we can go ahead and integrate this column with respect to time and this column with respect to time. That gives us the total mass of CO2 produced and oxygen adsorbed to the surface. Okay, so we create a table like this. So the first three columns are exactly taken from the table. Now we're going to go and calculate the integral of CO2 dt, basically this column times dt. And we know that how to do this we're using trapezoidal method. So the first point for integration is 0. The second point would be the area of a trapezoid between these 2 points. So it's going to be the sum of the two bases, right? That is b4 plus b3, and then times half of the height, which is a4 minus a3 divided by 2. Okay, so that is going to be the area under this trapezoid, or under the curve from here to here, and then we have to accumulate the result. So that is plus d3, which we calculate to be 0 for the previous cell. Okay, we hit enter, we just drag this thing all the way down. Oops. Drag this one down, and that's going to be 168.35 gram of CO2. Okay, we can do the same thing for O2. All we do is just, the first one is 0, the second one I'm going to drag it to the right. You have to write it because the equation for time is so the cell references for time column doesn't have a frozen index, so we cannot actually drag it to the right. I'm going to rewrite it again. Okay, so then the integral of O2 rate will be sum of the bases here, which means C4 plus C3 divided by 2, and then times the height, which is the difference between these two. And this, because I didn't freeze the difference between the time values, I couldn't actually drag it to the right. But if you write it in a way that you freeze the letter index, then you can also drag it to the right. Anyways, so I write it again. I highlight this and drag it down. So this is going to be the total mass of oxygen taken up by the reaction. Okay. So now what we can do is we can compare our result with sort of semi-analytical solution. And by semi-analytical solution, I mean we can draw the data points for CO2 and O2 versus time on a graph like this. So the blue dots are the CO2 rate, and the black dots are the O2 rate as a function of time. Then I can go and fit a curve to each set of data points. For black data points, I'm going to right click on data and then add trend line. And let's say I do polynomial of degree 2. So it's going to be that. Fortunately, my Excel crashed, so let me just reopen it. Open. Let's see. Okay. It's a bit slow here. Okay, I do the same thing to draw a regression line to the blue data points. So I'm going to click on my blue data points, right click, add trend line, and then this time I'm going to do linear. And there's a reason, because if you do, if you do a logarithmic or polynomial, it would be similar to, by eye you can easily see, it would be similar to linear. Okay, so anyways, let me just get rid of that. So this is, okay, so I think I did parabola to both data points. So for this, I get a curve with this equation. And for the blue points, or CO2, I get a curve with this equation. So this is the line that I fit. Okay, actually it's not a line, it's a parabola. Okay, so it's a second order equation in x, which means time in this case. And to show these equations again, once you click on your data points and you go to add trend line by holding down your right mouse key, and you go to options, and here you can say display. Okay, display equations on chart, you can see that, and if you just uncheck it, then it's going to go away. Anyways, so these are the equations I have. We can go ahead and integrate this. I just have these equations written here. For CO2, that's the fit, and for O2, that's the fit. If you integrate this with time, then you get the equation like that. I implemented already here. And what we do is, now we're going to plug in t equal to, well, now we're going to integrate this equation analytically from 140 to 140 for the first point, for the second point from 140 to 141, for the third point from 140 to 142, and so forth, right? So the first one actually you get 0, that's fine. The next one, we integrate over this equation from 141 to 140. So you have to plug in 140 first, then you subtract that from, you plug in 141. That's why I have equation here, all in terms of the time column right here. Okay, so that is the analytical integration. And then as soon as you write the equation for the second cell, you can drag it down. You do the same thing for O2 adsorption. We integrate this equation with respect to time. Okay. And then the lower limit would be 140, the upper limit would be 141 for this cell. For the next cell, again, the lower limit is 140, the upper limit is 142. Right? Let me just drag this thing down and then show you that is the same equation for other cells. Like for this cell, the limit of integration is from 140 to 142. So it's 140 and this is 142, which is sitting on cell A5. All right, so that is integration of the first piece right here. It's 0.0385 times t raised to second power. Now integrate, it becomes t raised to the third power divided by 3. And that is the third power right here. The second term is minus 11.355 divided by 2 times t raised to second power. And then the last one, which is the constant term, is 851.48 times t. And when you integrate from 140 to, let's say, a5, that's going to be the t term. Okay, so just to show you more details, and then just drag this guy down, and we see that the integral is this. So now compare the approximation using trapezoidal method with maybe 10 intervals, and then compare it with the analytical, well, not really analytical, we just did the analytical integration of the fit, which is really close. So 168 against 170, and for O2, the numerical approximation is 145 against 147. So they're close enough. Okay. All right, so that was how we can use trend line and show the equations on the curve using spreadsheet. I think this is the end of chapter 4. Thanks so much for watching. Stay tuned for the next video on chapter 5.